Hello everyone, I'm Siddharthan. In this video, let's understand how we can build a Streamlit chatbot where the user can chat with a document. So we can upload a PDF file from this upload button and ask questions based on that particular document. On the back end, we have connected this to a Groq LLM API using which we will be answering the question, and the exact LLM uses Llama 3.1. So we have worked on a previous version where the user can select a file and ask a particular question and they can get an answer. But we didn't have that chatbot interface where we are passing this entire chat history and we are not like continuing that conversation. But this particular version tries to address that issue where the user can keep on asking questions and the LLM will also get the context of the previous question and answer. So it's like kind of a conversational chatbot. So this will be the agenda for today's video, and let's get started. So this is how the final application would look like in Streamlit, and now let's just start with the coding aspects. So this is the code that's currently running here. I'll just create a new environment where we can work on this particular thing. So here I have this requirements.txt file, which is the first step. So we need all these libraries. So first we have python.env in order to save the Groq API key to the .env file. So later we will store this to an environment variable, and there we can get that particular API key. So the reason for using this is we shouldn't explicitly mention any API keys or secrets. So for that we have this, and of course Streamlit for the user interface, Langchain community for creating the chains and other file loading purposes and so on. So we have this Langchain community for those different purposes, and Langchain text splitters in order to read a file and split it into kind of like different chunks. And then we have Langchain Groq in order to access the LLM API, and then we have unstructured and unstructured PDF. So along with this Langchain community, we'll be using this unstructured PDF in order to read this file and extract the text. So once this text has been extracted, this will be passed to the text splitter in order to chunk that particular document data. And then we have this FASS GPU in order to do this similarity search of vector embeddings that we will create from the text chunks. And a particular issue about this FASS GPU is that in Python 3.12 version, it's kind of giving an issue for this particular version. So the version that I'm running now is 3.10.12, so I'm not facing any issues. But if you are on 3.12 or some other versions, you may have to consider using FASS CPU. And if you're also on Mac and Apple devices, you probably have to use the CPU versions, as this GPU is intended to go with NVIDIA GPU. So that's another thing that you can keep in mind. So you can replace this with the CPU version of the library. And then you have transformers and sentence transformers. Transformers is basically the Hugging Face library. So we need this in order to use the Hugging Face embeddings model, which we'll be using in order to convert our text chunks into vector embeddings. And that vector embeddings is basically used to do a similarity search between the question and actual document data. And then we have this NLTK. So this NLTK is kind of installed when we install unstructured PDF, but the latest version is giving us some issues. So I've gone to a previous version, which is like 3.8.1, and I'm not getting any issues here. And apart from this, you may also have to install Tesseract in your machine. So probably you may get some error when loading this unstructured thing. So you can just do a installation. So you need to install a separate software if you are on Windows for Tesseract, and if you are on Linux, you can just use this apt-get and so on. So you can install Tesseract. So these are all the dependencies that we need. So I hope that everyone is clear with this requirements.txt. You can just install it with pip install -r requirements.txt. So this will install all the libraries that's present. I'll also share the code that you're seeing here in probably in Git repository or somewhere. So this is the first step. So as you can see, I've already installed all these libraries. I'm just going to clear this and start working on it. And this is my project directory, RAG chatbot Groq, and within that I have my virtual environment, and it's always better to have separate virtual environment for separate projects. So now I'm going to create another directory called as src, which stands for source code. And then we have this requirements.txt. So the folder structure is that you have a src folder and then you have requirements.txt folder. So these are some of the standards that we can follow. So within this src, I'm going to create two files. One is the main.py file, where we will be having the Streamlit and other pieces of code, and then we can create a .env file where we are going to store our API keys. So the other way of doing this is to store this in a config.json file instead of .env. You can use that JSON file as well. So that's like much convenient. So now we have to get the Groq API key. So for that, you can just go to Google and search for Groq or Groq API key. So maybe I'll just search Groq. And you have to create an account with Groq, so you can just sign up with Google and other aspects. So that's a pretty easy process and straightforward. So in this groq.com, you will see this developer and start building. So click that. So from here we can create our API keys. So click on that API keys. So this is like the previous API key that I have created. So I can create a new API key with this button. So you can just say that this is for RAG chatbot or something. So I'll see this API key, so I'll copy this, so you won't be able to see this again. So if you kind of forgot to save this somewhere, you won't be able to see this. So you have to delete and create a new key. So here I can just say, we shouldn't put any quotes or something in this .env file. So you just have to say Groq API key is equal to, paste this thing. So this shouldn't change, this Groq API key shouldn't change, because we will be using this Langchain Groq and it will look for the API key in this particular environment variable. So this shouldn't change. So it's like uppercase letters of Groq API key with underscores. Okay, so these are the things that we need in our .env file. So now I'll close this one and let's start with the actual Streamlit code and the process of loading the LLM and other aspects. So first I'll do all the import statements. So I'm going to import OS in order to access this .env file and basically to access this working directory as well. So if you want to get the particular API key from this environment variable, so for that also you can use this OS library, and then from .env, which is nothing but the python.env library that we have installed. So from .env import load.env and then import Streamlit as st. So the next thing is from Langchain community document loaders import unstructured PDF loader. So I'll explain you the purpose of all these import statements once I'm done. So the next thing that we need is Langchain text splitters dot character import character text splitter from Langchain community dot vector stores. So for vector store, it's not like you have to use only FASs. So you can also use open source vector DB like Chroma and other things as well. So here we can just go with FASs, and then from Langchain community dot embeddings import Hugging Face embeddings, and then from Langchain community, we need to import Langchain Groq, import chat Groq, Langchain dot chains import conversational retrieval chain, and we also need to import the memory aspect. So this is used to store the previous questions and answers. So for this I can say from Langchain dot memory import conversational buffer memory. So these are all the things that we need. So let's probably try to understand this. I'm just trying to see if I've imported all those statements. So .env Streamlit oh, there is another conversational chain. So let me delete this one. Okay, so let's understand this. As I said, so we have this OS mainly in order to access the working directory, which is this src and other things, so that you can mention the entire file path. And then you have this load.env to store the API key to your environment variables so that the Groq and other libraries can use this. And then we have Streamlit for the user interface building, and then we have unstructured PDF loader used to read the PDF file and extract the text from it. So once that text has been extracted, we will be using character text splitter from Langchain text splitter in order to chunk this data into smaller chunks. And then we have vector stores. Okay, so I have to say import. So from Langchain community.vector stores, we are using FASs. So FASs stands for Facebook AI similarity search. So basically Meta developed this. This is a similarity, vector similarity search library used to compare the vectors and try to retrieve like the similar vectors. So that's the basic idea of RAG as well. So we have this question vector and you have this document vector. So we kind of find the similar vector in the document based on the question that you have. So that's why this is used to do that similarity search. And then we have embeddings. We are using this Hugging Face embeddings. So this Hugging Face embeddings will be used to convert your text chunks into vector embeddings and later will be stored in FASs. And then chat Groq in order to access the Llama 3.1 and other basically LLMs in Groq. And the other advantage of Groq is that it could give you like lightning fast inferences. So the answers that you're going to get from the LLM is going to be like pretty fast. So that's another advantage. And you don't have to sign up with any payment options or something. You can just work with free tier. So there are like enough usage limit for development. So you can use that. And then we have Langchain memory, and we are using this conversational buffer memory, which is going to hold the memory of the previous questions and the answers. So basically your chat history. So using that, the LLM kind of now as the context of what's the previous question and answer is, so that the user can have a conversation kind of a chatbot experience instead of just asking one question and getting one answer. So we have this chat history thing stored in this buffer memory. And then from conversation Langchain.chains, we have conversational retrieval chain, which is the chain that we'll be using here. So you have like different chains. So retrieval QA, which is used for a single question answering thing. You have graph QA, where if you are working with graph rack, if you're working with graph databases, so you'll be using that in order to connect to it and so on. So the one that we are using is conversational retrieval chain, as we want to build a conversational chatbot. So these are the things that we need. And then load the environment variables. So our API key is present in this .env, right? So we have to load this to the environment variable as Groq API key. So in order to do that, you can just call this function. So this will save the values present in this in environment variable. So later this library, so Langchain Groq, will need this in order to access Groq LLM. So that kind of done with load.env. So your API key is basically saved as one of the environment variables. So we need that for that purpose. And the next aspect is working directory is equal to os.path.directory name. And within this, I can say os.path.absolute path of file. So this is like a very important thing. So if you don't have this, you are probably going to get some errors when you're accessing some files. So the process by which this works is, so once the user has uploaded a file, right? So once they are uploaded a file, so we will store this in this src directory. Now the problem is, when you run your Streamlit app with Streamlit run command, it won't run in this particular project directory. So it's probably like it runs from the user directory where Python is installed. So if you just say the name of the file, it won't look in this src directory, but the working directory in which the code has been running. So now what we have to do is, whenever you are mentioning the path of a file, you need to give this entire path. So the entire path is this one. So my PC work, YTML and so on. So this is like a long path, right? So what I can do is mention that entire path. But when I share this code with you, you probably have to change this based on your working directory. So you probably have like different folder names. So you have to change this. In order to avoid that, we are using this working directory where we can automatically pick up the working directory, which is src. So how this works is, we are getting the absolute path of the file. So in this case, this _file . So this actually means this main.py file. So where this is present. So this will get the entire path of the main.py file. So it will be like src. So this is what we would get if I just copy the path. This is the absolute path. So this is what I would get when I run this os.path.absolute path of file. So from this entire path, I want only the directory name. So the directory name is like the src, right? So not only the directory name, but the entire path of the directory. So this is what I get. So once the user has uploaded it, once we have saved this to src, now we can access the file by mentioning this entire path. So that's the idea. So it's just to, instead of copying and pasting this entire path of src, I'm going to pick that up automatically using this code. So that's the process that we have for this working directory. So this is like a single line of code, but it's kind of like tricky and important that we have to use this. So that's about it. So now let's create like 3 functions in order to load the document, get the vector embeddings, and and create a chain. So we can do that now. So I'll create a function and say load document. And within this we have to pass the file path, so the entire path of the file. And now we can load this. So I'll say loader is equal to unstructured file loader, which we have already imported. Sorry, unstructured PDF loader. And we have to mention the file path, and later say documents is equal to loader.load. So this will read the data and extract the text and store this in a document format within like this unstructured thing, and then return this documents. So this is basically to read the file and extract the text from it. And then I'm going to create another function and call this as setup vector store. So the purpose of this one is you have read the document and extracted the text, and this text is going to be chunked and stored into a vector database. So here the input will be the documents that we get from the previous function. So these functions should be called sequentially. So later I can say we have to load the embedding model. Embeddings is equal to Hugging Face embeddings, and text splitter is equal to character text splitter, and the parameters that we have to mention are separator can be a new line separator, chunk size can be, let's say, 1000, and chunk overlap. So these are like basic things, and we have already discussed about these things, so I'm just skipping it. So like what's the size of the chunks and how much overlap should be there, so that there is some context between one chunk and the other chunk. So that's about it. And finally we can create, so this is like the instance of this text splitter. Character text splitter is stored in this variable called a text splitter. Now we are going to create the actual chunks for this document. So I'll say doc chunks is equal to text splitter, which we have created, dot split documents, because it's kind of a document format, not the text format, not the string format. So you have to say text splitter dot split documents. So in between you can also check the type of all these variables, documents and other details, if you want a clear understanding. So here the input will be the documents that's kind of getting passed, and then we can set up the vector store. So say vector store is equal to FASs that we have imported dot from documents doc chunks comma embeddings, and finally return your vector store. So these are the things that we need. Okay, so let's try to understand this. So first we are reading this document and extracting the text using unstructured PDF loader, and once we get this text, we are using a embedding model, which is Hugging Face embeddings in this case. So this should have a parenthesis. So we have this Hugging Face embeddings, and then using a character text splitter. So first the text will be chunked into smaller chunks, and then we convert this smaller chunks, which is stored in this variable, using this vector embedding model and storing this in FASs thing and returning this vector store. It's like it creates this vector DB in memory with this FASs, and we'll be using that in order to do the similarity search and get the relevant content, and then pass that relevant content to the LLM so that it asks the question and answer. Now it just frames the answer that the user needs. So that's the concept of RAG. So I hope you know the working of RAG. If not, refer to one of my videos. I'll probably give a link in the video description. So I've explained the concept of how RAG works, retrieval augmented generation works, and so on. So you can refer to that. So it's a simple video on the conceptual aspects of RAG. So it's probably will be useful to you. So and then I'll say create chain. So here we are going to create a chain from Langchain, and the input for this is vector store that we have created in the previous function. So all these 3 functions should kind of happen once the user has uploaded the file. So that's why we need this, and I'll probably stop the application because it may give some memory error because of the embedding model. So So I'll just like have this minimized. So it probably gives an error now. Okay. So create chain vector store. So now I can say, so first we have to load the LLM. So for that you can say LLM is equal to chat Groq that we have imported from Langchain Groq. And then within this we have to say the model name. So model is equal to, I'm going to use the Llama 3.1 model. So just go to groq.com, developers, start building. You can see the documentation and the models list. So these are all the different models that you can try. So you can also use like Gamma and other things, but I'll just go with, Llama 3.1 70 billion versatiles. This is the model that I'm going to use, the 70 billion version. You can try other things as well. So 70 billion versatile and temperature. There are also other parameters, but I'm just sticking to the minimum things. So temperature is like how random your answers to be. So if you ask a particular question and the temperature value ranges from 0 and 1. So if you ask a question and the value is 0 or closer to 0, you'll probably get like similar answers every time. So if the value is closer to 1, the model kind of slightly changes the answer for that question. So that's about that temperature thing. And then we have this retriever is equal to vector store dot as retriever. So this vector store is going to be used as kind of a retriever where we do a similarity search of question vector and the document vectors and just like send the relevant information as and this is the use of this. I'm going to say as retriever vector store dot as retriever, and then we are going to use the important aspect, which is memory is equal to conversational buffer memory. And the parameters that we need are memory is equal to LLM. So we have to first pass the LLM and output key is equal to answer and memory key is equal to chat history, and finally you can say return messages. So these are like some parameters. I'll explain you. So what this will do is whenever we call this LLM, so this is from Langchain conversational buffer memory. So whenever we call this LLM, the question and answer will be saved in a key value pair called as chat history. So we get this response from the LLM, right? So that would contain the question that the user is asking. The answer is stored in the key called as answer. So we can set this up. So we can say that I want the answer to be in a key value pair and that key should be named as answer. And we can say that the chat history should be in a key called as chat history. So it's basically, it would return you a dictionary, and here you're saying like what's the name of the key should be for the dictionary. So in this chat history, we have the previous conversation, and whenever we call this LLM, so this entire chat history will be passed to the model so that it understands the context, as I said before. So we are maintaining this conversation buffer memory using this particular function so that it understands the context, and later we can create this chain. So I can say that chain is equal to conversational retrieval chain dot from LLM, and here you can say LLM is equal to LLM. This is like the chat Groq that we have created, which we are also passing to the memory, and retriever is equal to the retriever that we have created over here, the vector stores retriever, which has all those vector embeddings, and memory is the conversation buffer memory that we have created in the previous step. And finally you can set verbose to true or false. So verbose, it kind of gives you the intermediate steps, so it prints the intermediate steps and so on. So it's good to have that as well. And finally we can return the chain. Okay, so these are the three functions that we need. So first we have this load documents thing. So first, once the user has uploaded a file, we are going to read that file and store this, basically extract the text and then pass the text to the setup vector store, which will use a Hugging Face, basically the Hugging Face embedding model, and convert this text document chunks into vector embeddings and store that in the vector store with FASs for similarity search. And then we have this create chain. create chain is used to kind of create this conversational retrieval chain, but we are using this LLM retriever as the vector store and memory, so that the LLM has the context of the previous question and answer, and we are returning the chain. So this is all about the core functionalities, like how we are creating a chain, LLM, and so on. So this is like one part of this code. So the second part of the code is building the user interface that you're seeing this. So how you can create this tab name, tab icon, so title of this, how you can create this upload file, question and answer thing, this chat interface and so on. So this is the second step, and that's what we are going to do now. Okay. The first thing that I'm going to set up is the page configuration. So I can say st.set page config, and within this we have three parameters. One is your page title, and maybe let's call this as chat with doc, just like the one that we have seen here. So when I say page title, this one, so we have this tab names and tab icons, right? So that's what we are setting up with this page config thing. Next is the page icon. Again, all these are like optional, so if you don't do this, you will just see the Streamlit icon with the tab name as main. So we don't want that, so that's why I'm setting up the configuration. So for this we can use emoji. So here I'm just using a document emoji, so you can just search emoji of document or something. So emoji DB is actually like a good thing to find these things. I can just say, just like copy this document thing and paste it over here. And the next parameter that I'm going to mention is the layout. So for layout we have two options. One is wide and the other one is centered. So I'll go with the centered version, which kind of looks like this, right? So we have all this content in the center of the page. So that's what this layout basically means. If you use wide, then you would see this entire thing in a wide spread format in this entire page. So that's the difference. So we are done with the page configuration thing. So now I'm going to give this title, which is chat with doc Llama 3.1. So we can do that. So I'll say st.title. So these are pretty basic steps. So if you have already worked on Streamlit, so you probably know this already. So I'll just say chat with doc and I'll say Llama 3.1. So put this in a string, and again I'm going to use a llama emoji. So I'll come back to emoji DB and say llama. I can copy this and paste it over here. Again, all these are like optional, so you don't have to do this. Like this is not like a mandatory stuff or something. So next we are going to initialize the chat history. So I'll say initialize the chat history in Streamlit session state. So Streamlit kind of continuously renders the stuff, renders tabs and so on. So we need to put some of these stuffs in the session state so that few aspects, some variables doesn't change when you click on some buttons and so on. So that's why we are using the Streamlit session state in order to maintain the variables and some data in a particular session. So in this case, the reason that we are using this session state is that when a user sends a message and get a response, it will be rendered when they send another question. So we don't want to lose that information. So for that, we will be storing all that information in the session state. So I'll say if chat history not in st.session state, I'm going to initiate it with st.session state dot chat history. So chat history is basically a list. So I can say chat history is equal to this thing. So within this, we will store all the users' questions and the assistant's response and so on. So here we are creating this list called as chat history within this Streamlit session state. So this st is nothing but the Streamlit library that we have imported over here. Okay. So now let's create a upload tab. So I'll say uploaded file is equal to st.file uploader, and within that we can put a label. So I'll say label is equal to, or you can just put this in the same line. So label is equal to upload your PDF file. So I'm just sticking to PDF, but you can also instead of unstructured PDF loader, you can use unstructured file loader and include a broad variety of documents. So in this type, I'm going to just say, PDF, but let's say you want to include documents, docx format and other aspects, you can include that doc as well. And instead of PDF loader, you can write some if conditions to use either PDF loader or docx loader and so on. So you can try that. So only difference is that you would, along with this unstructured PDF, you would also install unstructured docx version. So that's maybe something that you can try as an assignment. So yeah, so this is for uploaded file. So this basically creates this file uploader widget and the user can upload it. So once they have uploaded a file, so that particular file data will be stored in this variable called as uploaded file. So that's the purpose of this particular variable. Once this file has been uploaded, we are going to do these steps as I've said earlier. So once the user has uploaded a file, we will load this document, get the text, set up the vector store and create the chain. So all these should happen once the user has uploaded a file. So for that, we can say if uploaded file. So this means initially, before the time the user has uploaded a file, uploaded file will be a none data type. So this if condition won't run if this is none. So this none changes to some value once they have uploaded a file, right? So this is what we are saying. So this is like in simple words, I can say this if condition or if block will run only after the user has uploaded something in this upload file widget. So once they have uploaded it, I'm going to say a file path is equal to f of working directory. So f is basically like you can substitute the strings and so on. So I'll say working directory slash uploaded file dot name. So uploaded file dot name gives you the name of the file. So in this case, let's say attention is all you need. .pdf is the name of the file. So you can get this from uploaded file dot name, and we are storing this in this working directory within this src directory. And if you remember, we got this working directory in the first step using this os.path and so on. So that's the thing. And I can say with open file path comma wb. So we are storing this particular file in this src directory as f.write uploaded file dot get buffer and say let's understand this. So we have this file path saying that it should be in src slash the file name. So once the user has uploaded this, we are going to save that file in this src directory, and that's what we are doing this. So we have mentioned the full path of the file, the particular directory or the location where we want the file to be saved with the name as well. Or you can also change this name. So you can say that rag document or something, a generic name instead of the name of the document that the user has uploaded. So you can do that as well, but I would suggest to use the same name. So we are going with uploaded file dot name and this two lines. So we are giving this path and we are saving that particular file. So writing this file in this src directory. So after this has been done, we have to call these functions. So here we kind of pass the file path and call the other functions, right? So those things should be done. So here I'll say if vector store not in st.session state, then st.session state dot vector store is equal to setup vector store, which is the function that we have, and within this we can say load documents and file path, right? So this is the load documents function. So instead of calling this in a separate line, I'm just like calling this within the setup vector store. So first we have the setup vector store, within that I'm calling this load documents file path. So it's basically like calling these two functions. So setup vector stores and the documents is coming from this load documents thing. So that's what we have. So this will first call the load document function, pass in the file path, and this function will return you the text data, the documents, basically the extracted text, right? And then this text, right, so the output of this function, which is basically the text that we have extracted from the file, is then passed on to this setup vector store function, right? And then we return this vector store, and that's stored in st.session_state.vector store. And the critical thing that you have to understand here is, you can think that why we can't do this. So you can just say vector store is equal to setup vector store and then pass the documents. You can do something like this. So you can think that why can't we do this? So the problem is, as I said earlier in the initial part of this video, Streamlit kind of renders these things again, right? And because of that, if you just say vector store is equal to setup vector stores, it renders when the user has clicked a button and when they have like sent a new message, new question and so on. It will again call this setup vector stores, create chain and so on. So at each time it will do the steps again and again of reading the file, setting up the vector store and so on. The problem with this is you don't want the same step to be happening again and again, because the user is going to ask the question from the same document, right, for one particular session. That's one issue. And the other important issue is when this create chain has been called again and again, this memory variable is created again and again. So it's like kind of a new instance of this memory. So when you do that, the previous question and answers that you have stored in this chat history are kind of deleted, or they are kind of reset. So we don't want that to happen. So if that happens, the LLM cannot have the context of the previous conversation. So I hope this makes sense, but probably I'll explain this again in simple words. So just think about this as Streamlit renders stuff. So few of these lines can run again and again when a particular button is clicked or the user is asking a question. But when it renders it again, you create a new chain and you create a new memory. So when a new memory is created, the previous conversation is lost. The previous question and answer is lost. So instead of doing this, of creating vector store is equal to setup vector stores, we are going to create the vector stores only at the start. So this says if vector store is not in st.session state, then only create this vector store. That means initially when the user has uploaded a file, when the execution happens for line 79, vector store won't be in session state. Session state will only contain chat history. So in that case only we will create this vector store within the session state and again load the documents and do the stuff. Now when Streamlit renders stuff again, now it again comes back to 79. Session state data won't get refreshed, so it won't get reset. So as we have already created the vector store in the session state, this won't be executed, and because of that we won't create the vector store again. Now I can do the same thing, say that if let's call this conversation chain. Okay, so conversation chain not in st.session state. In that case, say st.session state dot conversation chain, the exact thing. Conversation chain is equal to create chain function, and within that you can pass st.session state, not just vector store but st.session state vector store. So what happens is, even when Streamlit renders few steps again, conversation chain would have been already created, so this part won't run. So we won't create a new chain and a new memory, right? So that's the purpose of this. So it's basically to save the variable, save the data in session state aspects of Streamlit, so that we are not creating the vector stores again, and more importantly we don't create the conversation chain again, because if you don't do this, the memory will be lost and we won't be having the reference of previous question and answers. So that's about it. So when the user uploads the file for this first time, vector store won't be in session state, so we create a vector store, and again conversation chain won't be in the vector store, we are creating it. But when it renders again, when a new question is asked, it will again check for this if condition and it won't be satisfied. So this will only run if vector store is not in session state, but it will be there because we have already created it. So this is a bit complex, but again once you try this and just look at this code in a detailed way, you probably would get a better understanding. So I'm just moving on to the next one, hoping that you get this part. But if you have any doubts, please mention in the comments. I'll be happy to answer this, as this is kind of a tricky thing to get a hang of. So yeah. So once we have created this vector store and conversation chain, and the other thing I can mention is, like, once the user refreshes the page, then all these are kind of rendered again. So session state will be cleared, all these are rendered again. But when they ask a new question, we don't want to lose that at the time. So that's why we are using this. So we shouldn't retain it once the page has been refreshed, right? So that's other different thing that you need to remember. So let's move on to the next step of displaying the previous messages. So I'll say for message in st.session state.chat history. So now we are going to display the previous question and answers. So let's say the user is asking a question, right? So we need to display the previous questions and answers, and that we are doing with a for loop. So we look at the chat history data, chat history list in the session state, and using that we can say with st.chat message, and messages from the role st.markdown. I'll maybe complete this and explain this content to you. So we have like few lines of code. I'll complete this and explain all these lines. So here I'll say message of content, and then we have this user input. So user input is equal to st.chat input, and then that you can say as Llama. We can do something like this. Again, you can mention anything. This chat input is nothing but this message box and the send button that you're seeing over here. So this is created, this chat widget is created by using this st.chat input from Streamlit. So now once the user has typed in something and clicked on the send message, we have to run the other lines, which is if user input. Again, this will turn to true only if the user has typed in something and clicked on the send button. So if user input, previously it will be none, so this won't be executed when there is nothing. So yeah, I can say st.session state. We don't need to do this. So I can say st.session state dot chat history dot append role would be user, and we have the content as the user input. Okay, and then I can say with st.chat message, and this will be the user, st.markdown, user input, and finally we have the assistant response. So we can say with st.chat message assistant, put this in double quotes, response. So this is where we are going to call the model. So I'll say st.session state dot conversation chain, which is nothing but the chain that we have created, the conversational retrieval chain, which is stored in this st.session state dot conversation chain. So conversation chain, you can say question user input, and finally st.markdown response of answer, and finally st.session state dot chat history dot append this entire thing we can also store this in assistant response. Response is equal to response of answer, which is a string, and we can use that variable in order to display this. And finally we can copy this role of user and paste it over here and change this to assistant, and content will be the assistant response. So this is the complete code. Now let's try to understand this. So first I'll just explain what this chat message does. st.chat message or streamlit.chat message is what you're seeing here. So you're seeing this little box and you're seeing this red emoji, right? So this is kind of created using this st.markdown. So st.markdown user input is nothing but this is being displayed in a markdown format. and you're seeing this red color icon, right? So that comes from st.chat message of user. So when st.chat message takes in the parameter of user, it's going to create a human face emoji. When st.chat message is assistant, it's going to create a robot face with this yellow colored emoji. So that's the difference between this with st.chat message and with st.chat message of assistant. So when you say with st.chat message of user, st.markdown of user input, it's going to show this red colored emoji, and within that it's going to display this text in the markdown. So that's what we are seeing this. So when I say st.chat message of user, so beside that red color human face emoji, as this is a user, display this user's input in markdown. So this is just displaying the question asked by the user in markdown format. And once that has been done, once we display this user's question, we call the LLM and get the response from the assistant. Assistant is nothing but LLM in this case. So when I say with st.chat message of assistant, it will display this yellow colored robot box and display this content in markdown. So where this content is coming from, so that we have to understand. So we have this response is equal to st.session state conversation chain. So we are invoking this conversation chain, and this conversation chain is nothing but the create chain function that we have, and within that we have this retriever, memory, LLM, and so on. So retriever is the vector database of the document and so on, and this will return the chain, right? So we are invoking the chain and passing the user's question. So this conversation basically takes in the user's question. It also takes in the retriever or the vector database that we have created, and also the memory. So we have this buffer memory. So from the previous question and answer, it kind of stores this as a buffer memory. And with all this, it sends this question along with the chat history, along with the data retrieved from the vector database to the LLM, to the Groq LLM API. And from there we get the response, and that's stored in this response variable. And the final answer that you need is stored in the key called as answer. But how do I know that it's stored in the key called as answer? That's because here we have mentioned that the output key should be answer, and it's usually the key that contains your answer. So you mention this answer, and you're storing that in the variable called as assistant response and displaying this with st.markdown of assistant response. So this is what you're seeing here. So we are, once the user has submitted or asked a question, so we send this to the Groq API, get this response and display this as markdown within this st.chat message of assistant that we have over here. So within this assistant block, within this yellow colored emoji block, so we are displaying this particular message, and in each step we are storing this to the chat history which is present within the session state. So even if you see here, right, once the user has asked a question, we will store this. Once the assistant has responded, even then we also store this. So this is the idea. And maybe one critical thing that you need to now understand is like how this chat history will look like. As I said, this is like a empty list that we are creating at the start, so we are initializing it. So this would, let's say, look something like this. So it is a list and it would contain like several dictionaries, right? So let me give you an example. So first it will look something like this. So role of user, and content is, let's say the user is asking, what is a LLM? And now we would have the response from the LLM, from the model. Let's say the user has asked this previously and the LLM has given a response. So in the role, now it would say this role as assistant, and it would just go on and explain this as LLM is a large language model, or like whatever the answer that it's giving. Now let's say the user is asking a question, something like, I didn't understand this properly. So the user is going to say, explain in detail. So when the user just says explain in detail, the LLM doesn't have a context of what the user want me to explain in detail. So the LLM doesn't know that. But when you give this previous question and answer, now the LLM knows that the user is asking us to explain in detail about LLM. So now it would just explain LLM, in a detailed way, or like whatever it is, right? So this is how the chat history will look like. So in order to get the context of a particular question, we look at the previous question and answer itself. So all those things are kind of stored in chat history, and in a way the conversational buffer memory holds all this chat history thing, right? So that's how the LLM kind of gets to know this, and this is the memory that we are using in our chain. So if you don't use this memory, you won't be able to populate or send this memory to the LLM and so on. So that's about it. And in the for loop, so once the user has 3 or 4 questions, right, so we need to display all those questions and answers. So that's why we are using this for loop. So for message and chat history, so it goes through all the individual dictionary in the chat history and display with st.chat message role. So this is basically what we have. Oh, sorry. So this is basically what we have over here. So whether it's user or assistant, but user assistant is picked up from the chat history itself. So message role will contain either user or the role, and content is like the actual content, right? So whenever it's the role is user, it has this human emoji. Whenever the role is assistant, it has this red robot emoji. So this is how it works. Maybe I'll run this Streamlit app and let's ask a question and make sure that everything is working. So if you don't understand few of these aspects of this question and answer thing, that's completely fine. I'll just give you a recap and I know explain a few things in a simple way so that you are clear with everything. But first let's run this thing. So you have to say streamlit run src slash main.py because my main.py file is within this src directory, and if you see this, I'm running this from my project directory, which is rat chatbot Groq, and within this I have this src and main.py. So I can say streamlit run src slash main.py. So we have this uploaded file widget created, chat input, and like all those details. Now I'll go and browse the files. So I have this paper of attention is all you need, which is the paper that came on transformers, just a simple PDF that we need for now. So I'll upload this. So once I upload this, those 3 things will happen. So one is like loading this document text, creating the vector store, and finally creating a chain. So I'll upload this. Let's see if anything is breaking within the code. The first time that you run this, it may take some time because it has to load the Hugging Face embedding model, which is about like 400 MB or something like that. So here you would see a warning of model download, and I think the other warning is about instead of using transformers and this is here. Okay, so instead of using Langchain community embeddings Hugging Face, it's suggesting us to use Langchain Hugging Face. So there is like another integrated version of Langchain Hugging Face. Maybe you can try this. So things won't change. You just have to install this library and replace this from Langchain community with this particular thing. Otherwise, like this is okay. So it's just a warning, but probably it will be deprecated in the future. So you can just replace this. So now I'm going to ask a question from this document. So there is a particular section in this document that talks about the applications of attention. So I'll just ask, what are the applications of attention in our model? So this is like the content that's present in this one of those sections of the document. So this does the vector search and send this relevant context to the LLM in Groq, and it will send us in response, and we are seeing this. So encoder, decoder, attention, self attention liaison in encoder and the decoder. You can refer to the document in order to verify this, but this is the answer that we need. So now we are going to say this, saying like explain in short. So now I'm not saying a context of explain the applications of attention in our model in short. So I'm not saying that. I want to make sure that the LLM has the context of the previous question and answers. I'm just saying without any context, explain in short. So basically it has to look at the previous response and revert back based on that. So let's see how that is working. If you see this again, it's not that much short, but the model kind of now knows that this is what we are kind of like talking about. So that's the basic idea, right? So it's like when you ask a particular question, it shouldn't be a standalone question, right? So that's about it. So it should be taking it from the previous question and answer and so on and answer from it. I can just ask like, just name the points or something. Okay, so I think we can use some of the refinement methods that we have. 1 second, in order to get better answers. So it's like we are not kind of getting shorter answers in this case. So there are like some adjustments that we can do to this. Let's do that. So we can do that on this chain thing that we have. Let me do that maybe. So in this conversational retrieval chain, and this works for other chains as well. So we have this parameter called as chain type. So I can say chain type is equal to, so there are like few types. One is like stuff, refine, map, reduce, and so on. And this kind of changes the way in which you're getting a response from this LLM, and there are like multiple calls involved in it based on the chain type that we are using. So I'll go with this map reduce thing. So this is like one of the effective ones. So again, you can try this stuff, refine, and so on. Maybe I'll explain in detail about these different chain types probably in a different video, as this is like a different topic that we need to pay attention to, but I'll just use a different chain type. So here I can say streamlit run src / main.py. Again, all those are same, only like the way we are getting a response from the LLM is going to change. So I'll upload this. Attention is all you need, this particular paper. So we are going to load the text, get the document data, and all those things. And now I'll probably ask the question of, again, the same question: what are the applications attention in our model? So now we would get a response. Okay, so it's giving in a shorter way. So we have this encoder decoder attention, self attention in the encoder, and self attention in the decoder. So this is the answer that we need. But let's say I'll ask this in explain in detail, as this is like slightly smaller. I'll say explain in detail. So now it has to answer this, but takes this context. So here I'm not saying that explain in detail about applications of attention, but just saying this. So the model has to look at the previous answer, question and answer, and give a response. So now as you can see, it says the transformer model uses this attention 3 different ways and so on. So it's basically the same stuff that you're seeing, but this is in a more detailed way. So this is how you can build a conversational chatbot that doesn't looks at one question and gives one answer at a time, but also has the context of the chat history and gives you the response based on this. So I hope everyone is clear until this point. I'll just give you a quick recap of what we have done so that everything is like clear to you. So first we have all those import statement that we need for Streamlit, Langchain, unstructured, and so on, Hugging Face embeddings, and all those details. And then we have this .env file, right, where we add this Groq API key. So we have this Groq API key and saving this in the environment variable using this load.env. And we are using this working directory. As you can see, once the user has uploaded this file, we are storing this in our working directory. So this is why we need this working directory thing to understand that like what's the particular directory is. And then we have the 3 functions of load documents, setting up the vector store, creating the chain, and so on. So all these are like called at a later stage. And then we have this streamlit title, title of the page, and we are initiating this chat history in session state. So if chat history not in session state, that means like it runs only in the initial step, because at the first place when it runs, chat history is not in the session state. So now we are initiating this. When Streamlit renders stuff again, it won't initiate it because chat history now it's already present in the session state. So the if block won't be satisfied. So this if block won't run. And then we are creating a uploaded file widget. And once the file has been uploaded, we are saving this to the working directory and then creating this vector store conversation chain, not just with just a simple variable, but we are storing this in session state and making sure that this only run once. So when the user refreshes the page and then they upload a file, now that would change, but before that it won't render again, it won't change again for every question and answer. So we are storing that in the session state thing. So once all those things are done, we are using this for loop to display the previous question. So you're seeing the first question and answer, and then you're seeing the second question and answer, right? So all these are done in the for loop. So when we refresh the page, this chat history will be empty list. So it would be an empty list, right? So this for loop won't run at all. So we are not seeing anything there because there is nothing to display in the chat history. After that, we have this user input, which is the chat message bar. And once the user has typed in something and clicked on the enter thing, this if condition is satisfied and the if block will get executed. So we are storing this user's question to the chat history and then displaying that here with this yellow emoji using this chat message of user, and within that we are representing this markdown. And then in this assistance block, this particular yellow robot emoji block, we are displaying it in markdown. And but before that we are calling this conversation chain thing that we have already created, getting the response, storing this in this assistant response variable from response of answer, and displaying it, and finally adding that to the chat history as well. So that's how you can create this conversational chatbot. So I hope that this is helpful to you, and please try this code. So you can try different variations of using Llama models, or you can also try using, ChromaDB and other aspects as well. So that is all from my side, and I'll see you in the next upload. Thanks for watching.